question 23 is about exponential functions. Okay, so it's about a petri dish and 20 bacteria. Okay, so here's the question, and let's see. And we'll work from there. Okay, so this is the question 23, and if you pause it here, you can read it a bit clearer. So I'll start with A and show how to work it out, and what the answers are. Okay, so for part A, it's asking for the population after each day for 1 week. So what we do here is, well, we look at what we're told. We're told that there are 20 bacteria on day initially, so that's day 0. So we want to try and find day 1. So what we do is we know also that we know that the number of bacteria triple after each day. So what we do, so I'll just write that there, 3. So how we work it out is we go the number of bacteria in this case, so 20, and then what we'll do is times it by the 3, because it's getting 3 times bigger each time. And then what we do is, depending on the number of day, we have t. So if we're looking for the first day, t is 1. If we're looking for the 6th day, t is 6. And it just carries on like that. So for this part, for the first day, we'll use 1 as t. So 23, and then this time we write a 1 there. So what we do is we go, and the answer to that, if you type it out on your calculator, you'll get 60. And then if you keep going, for the next one, what we'll do is go 20 times 3 to the power of 2. So this one is 180. And I'll just write out the next couple, just so, because it's a bit shorter. So after that it goes 540, 1620, 4860, and the 6th day is 14,580, and the last day of the week is 43,740. Okay, so basically, if you notice, each of these is getting 3 times bigger. So, as we said earlier, the number of bacteria has tripled. So that looks right then. So for part B, it's asking for an equation to model this growth. And what we do here is we write out we try and work out the equation. So we know the original number was 20, so it's 20, and it's getting 3 times bigger every time, so it's times 3, and as we showed earlier, t is the number of days. Okay, so after that, question C, pardon me, question C is asking to graph the relation, and is it a function, and why. So what we do here is we'll use these values we used in part A here as y values in the graph, and after each of these is a day. So on day 0 we have 20, day 1 60, 2 180, and so forth. And if you do that, you'll get a graph like this. And if you look, we know it's a function because for every y value on here, for every x value, there's only one y value, and so therefore it is a function. You can see if you draw lines, if there's anywhere where, let's say, if it goes like that or something where it crosses in two places, it's not a function. But since it doesn't, in this example, it is a function. So that's our answer for part C. And now on to D. D is asking is two parts. For the first part, it's asking to predict the population after 2 weeks. So here's what we do: is we go we write our equation, so 20 to the power of 3 to t, and then what we do is substitute 14 in instead of the t, because 14 is obviously 2 weeks. So what we'll do is here is 23, 14, which gives us the grand sum of 9, 5, 6, 5, 9, 3, 8, 0. Okay, so that's our value for the 14th value for how many bacteria are in there. So after this is part, so that's our answer for part I. DII is asking for the third week, how many there are. So there's 21 days in 3 weeks. So what we do is basically the exact same as in part I, and we go 20 to the power of 3, but this time instead of 14 we do 21, and then what you just plug it in on your calculator, and it should give you this 209 207 064 100. So that's the answer for part D. And the final question is part E, which is asking describe the pattern of finite differences for this relationship. So for this relationship, if you look, as we've seen earlier in part A, it's getting 3 times bigger. So I'm going to write here the answer as each stay, the difference in the number of bacteria goes up by a factor of 3. There we go. So that's all the questions in question 23, and I'm just going to show you the answers in the textbook to prove that I'm right and I explained it to you right. So if we just turn it over, and here we go. So this is the answer to part A, which gives you which shows you the values are 20, 60, 180, 540, 1620, and so forth. And if you look at our answers, they are correct. Okay, so now if we look at B, the answer here is 20 to the power of 3 to the t, which, as I showed, is the same here. So there we go. C, we've got this, which looks remarkably similar to the small graph there, except mine's being got a curve on it, like a line on it. So, and then it explains here that why it's a function in a little more concisely than me. However, it explains the same thing. And then for part D, which you can just about see, is the same value for both questions as I have right here, here and here, and then the answer for E is the same, as you can just about see. Even though it says answers may vary, as you can see, answers may vary. So there you go, that's how you work out question 23 on exponential functions. Bye.